Development of information system solution to business problems is a responsibility of any business professional today. As a business end user, he will have to initiate and provide inputs for development of effective information systems for his company. The business end user has the responsibility of using systems and continuously initiating improvements. As an IT manager, his responsibility will consist of managing the development efforts of information system specialists. The systems approach to problem solving uses a systems orientation to the process of developing an information system. The activities are interrelated and require the involvement of every business end user in addition to the IS professional. The system approach involves recognizing and defining the problem or opportunity, evaluating alternative system solutions, selecting the best fit solution, designing the selected solution, implementing and evaluating the success of the designed system. When a systems approach to problem solving is applied to the development of information system solution to business problems, it is called information system development or application development. However, before we look at the application development, we need to understand the information system architecture. The information system architecture is a conceptual framework for the organizational IT infrastructure. It is a plan for structure and integration of the information resources in the organization. The model of information system architecture comprises of two major parts. The centralized portion serves the entire organization and it includes the business architecture, the data architecture and the communication architecture. The decentralized portion focuses on an organizational function or on some service or activity. Each entity includes operational, managerial and strategic applications. One way to classify information system architecture is by the role the hardware plays. It is possible to distinguish two extreme cases, a mainframe environment and a PC environment. The combination of these two creates a third type of architecture, the distributed or networked environment. The internet, intranet and extranets are based on client-server architecture and enterprise-wide computing, the newest architectural concepts. The principle of these concepts are client-server architecture and enterprising-wide computing. A client-server arrangement divides network computing units into two major categories, client and servers, all of which are connected by LANs and possibly WANs. A client is a computer such as a PC or a workstation attached to a network which is used to access shared network resources. A server is a machine that provides client with these services. In some client-server systems, there are additional computing units, referred to as middleware. The purpose of client-server architecture is to maximize the use of computer resources. Client-server computing can be implemented in a small work area or in one department on LAN. Its main benefit is the sharing of resources within the department. However, many users frequently need access to data, applications, services, electronic mail and real-time flows of data, which are in different LANs or databases, so that they can improve their productivity and competitiveness. The solution is to deploy an enterprise-wide client-server architecture, that is to combine the two concepts to form a cohesive, flexible and powerful computing environment. The systems approach to developing information system solutions involves a staged process known as Systems Development Lifecycle or SDLC. Information System Lifecycle covers the planning, construction, deployment and maintenance of an information system. It covers the steps of investigating, analyzing, design and implementation and maintenance. The investigation stage includes a preliminary study of proposed information system solution to end-user business problems, known as feasibility study. Feasibility studies typically involve cost-benefit analysis. If costs and benefits can be quantified, they are called tangible. If not, they are called intangible. Before you design a new system, it is important to study the system that will be improved or replaced. Then comes system analysis, which is one of the most difficult steps. You may need to work as a team with system analysts and other end users to determine your specific business information needs. System analysis describes what a system should do to meet the information needs of users. System design specifies how the system will accomplish this objective. Systems design process generates the system specifications that satisfy the functional requirement identified in the earlier phase. Once a new information system has been designed, it must be implemented. The system implementation stage involves hardware and software acquisition, software developing, testing of programs and procedures, development of documentation, and a variety of installation activities. Finally, implementation involves the transition process from the use of the present system to the use of a new or improved application. Systems maintenance is the final stage of the information system lifecycle. It involves the monitoring, evaluation, and modification of a system to make desirable or necessary improvements. This is a continuous phase and includes a post-implementation review process to ensure that newly implemented systems is meeting the functional business requirements that were established for it when it was designed. Errors in the development of a system are corrected by the maintenance activity. Systems maintenance also includes modifying a system due to internal changes in a business or external changes in the business environment. Given the important role of software in business, great attention has been paid to designing effective processes for its development. Early attempts at standardizing a formal model for developing software date back to at least the 1960s. In response to the problems in managing large custom software development projects, the so-called waterfall model of software development was introduced. This model identified the separate stages that all software projects should include and give guidance on the condition that should be met in order that a project be allowed to proceed from one stage to another. The aim of the waterfall model was to bring control and discipline to what had previously been a rather unstructured and chaotic process. It involved progressing through a series of different stages, including requirements definition, specification, planning, design, implementation, and integration. While the waterfall model of development proved to be a successful response to early problems that had plagued software development, increasing dissatisfaction was expressed with its results in the years that followed. The criticism was especially strong in environments where considerable uncertainty surrounded either the product's customer requirement or its needed technical solutions. Beginning in the early 1980s, a host of more flexible models of development began to emerge, each seeking to address perceived shortfalls with the waterfall model. The first types of models that emerged to supplant the waterfall models were based upon the use of one or more prototypes to be shown to customers at an early stage, thereby gaining feedback based upon a representation of a product, as opposed to a text specification. The prototypes are thrown away after use. They are not an integral part of the product. The process that is subsequently used to detail the design is similar in nature to the waterfall model described above. The next series of models that emerged from efforts to improve flexibility in development are characterized by the fact that they involve developing subsets of products' functionality on an incremental basis. These are known as rapid development models. The primary objective of the incremental delivery models is to reduce risk in large projects by delivering subsets of the planned functionality to customers earlier in development. Development is split into a number of sub-cycles, each of which typically uses a mini waterfall process, resulting in complete subsystems that is delivered to the customers. The latest model is both incremental and iterative. This is called the spiral development model, which encompasses a feedback mechanism that allows it to rework features in these intermediate versions in response to customer feedback and reschedule subsequent activities in the light of new information generated when each subcycle is completed. The spiral development model combines the waterfall development model and the prototype approach, which is a serial of partial implementation of products. Advantages of the spiral development model include an early focus on reusing existing software components, the incorporation of software quality standards, and the integration of hardware and software development cycles. This step of system analysis is one of the most difficult one. You need to work as a team with system analysts and other end users to determine your specific business information need. System analysis is an in-depth study of end user information needs that produces functional requirements which are used as a basis for design of a new information system or implementation of packaged software. An organizational analysis is an important first step in system analysis. The members of a development team have to know something about the organization, its management structure, its people, its business activity, the environmental systems it must deal with, and its current information system. Based on the system analysis, software requirement specifications need to be identified. These are end-user information requirements that are not linked to the hardware, software, network, data, and people resources that end users presently use or might use in the new system. The main goal is to identify what should be done, not how to do it. This will help in preparing the user acceptance test plan. Software requirement analysis activities include identify the customer and work together to negotiate product-level requirements. Build an analysis by focusing on data, defining function and representing behavior. Prototype areas of uncertainty. Develop a specification that will guide design. Conduct formal technical reviews to validate the requirement. And develop a user acceptance test plan. System analysis describes what a system should do to meet the information needs of users. Systems design specifies how the system will accomplish this objective and generates the system specifications that satisfy functional requirement identification in the earlier phase. The design should be traceable to the analysis model. The design should minimize the intellectual distance between the software and the problem, and should be structured to accommodate change. The design should be reviewed to minimize conceptual errors. The overall structure of the software is the architecture of the software to be built. It is a representation that enables a software engineer to analyze the effectiveness of the design in meeting its stated requirements. Consider architectural alternatives at a stage when making design changes is still relatively easy, and reduce the risk associated with the construction of the software. The design phase translates the SRS into a workable solution and defines the database design, menu design, and input design. Software testing is the most tedious, unpredictable, and expensive phase in software development. To ease this, it is necessary to supplement testing with reviews. Software testing actually begins with design reviews and code walkthrough. These are pre-implementation tests which can identify a significant percentage of faults at the initial stages. The cost and effort associated with this is also far less than computer-based tests for the same purpose. Testing and reviews have to be planned and executed at various stages of the system cycle, so as to find defects in requirements, design, documentation, and code as early as possible. The features of various types of testing include unit testing, integration testing, system testing, and acceptance testing. In unit testing, the smallest testable component, which is termed as the unit, is tested for consistency with the program or process specifications. All important statements, branches, conditions, and paths are tested for expected results. Unit test plan, test cases, test data, and defect log are important documents to be prepared and stored for future reference and analysis. After that, the software component of the system is assembled into a module and tested for data integrity, configuration, and parameters. This is known as integration testing. It also helps identify resource problem and then ensures that the module works on environment. Integration testing can be bottom-up or top-down approach. It is followed by system testing. Software is but one part of a system that includes hardware, network, and users. The focus of system testing is on testing the complete integrated system with reference to system specifications. The tests address system characteristics such as performance, security, and recovery. Acceptance testing is also known as validation or functional testing. Acceptance testing demonstrates that software is operational and conforms to all functional and performance requirements documented in software requirement specifications. It verifies the operational flow and evaluates the fitness of the system on the field from the user's perspective. The testing process, as seen earlier, starts from the definition phase and is a set of activities such as preparation of test plan, definition of test design and criteria, identification of the test cases and data set, recording the results, debugging and correction, and definition of the next testing cycle. A test plan has to be prepared for each level of testing. This test plan defines the scope, approach, type, and the pass-fail suspension criteria. Testing should not be planned under the assumption that no errors will be found. Test items should cover invalid and unexpected input conditions as well as valid conditions. The test plan should identify the resources required, tasks and deliverables, schedule, features to be tested, test items, and risks. The test plan has to be documented and reviewed so as to confirm the feasibility and completeness of the testing. Effective planning of investments in IT by business unit managers is a key ingredient in achieving strategic business success with IT. Planning is deciding what to do before you do it and is an important factor of success. The process of organizational planning consists of team building, modeling and consensus, evaluating what has been accomplished and the resource required, analyzing the business, economic, political and societal environment, anticipating and evaluating the impact of future developments and opportunities, building a shared vision and deciding a goal to be achieved and identifying an action plan to achieve this goal. Information system planning is an important component of organizational planning. Strategic planning has four main objectives to be considered, namely business alignment, which includes aligning investment in IT with organization's business vision and strategic business rules. Competitive advantage involves exploitation of IT to create innovative and strategic business. Information systems for competitive advantage, resource management, which involves developing plans for the efficient and effective management of an organization's information system resource, including the IS personnel, hardware, software, data and network resource, and technology architecture, which involves developing technology policy and designing information technology architecture for the organization. Planning for competitive advantage is very critical in today's competitive and complex information technology environment. Strategic IS planning therefore involves an evaluation of potential benefits and the risks an organization faces when using IT for competitive advantage.